Alrighty, time for some late night hard coding. I don't feel great about this one. Alright, anyways, minimum 1-bit operations to make integer 0. Given integer n, you must transform it into 0 using the following operations any number of times. Change the rightmost the 0th bit in the 0th bit, in the binary representation of n. Change the ith bit in the binary representation of n if I minus 1th bit is set to 1 and I minus 2th through 0th bit are set to 0. Return the minimum number of operations to transform n into 0. Okay, I got like maybe 1% of that. Okay, you're given an integer, you must transform it to 0. Okay, so obviously if it's anything besides 0, there's going to be some 1s in it in the binary representation of it. So we can change the rightmost bit to 0. Okay, not maybe the most useful thing if it's not odd. Change the ith bit in the representation of n if I minus 1th bit is set to 1 and I minus 2th through 0th bit are set to 0. So you're toggling the ith bit, change the ith bit of n, change the ith bit, so you're toggling it a lot as well. You're toggling ith bit if the right bits from there is 1 and a bunch of zeros. Okay, I think I can understand that. Okay, n equals 3. N equals 3 means it's like 1, 1 in binary. So change the rightmost bit. So you change what you do here. You would make you make the rightmost bit into a 0. That's one operation. And then now you make the second bit into you make that middle bit into 0. Change the ith bit. Yeah. As long as the next one is 1 followed by zeros. And then you make the last one 0. Okay, 1, 1, 0, 1, second operation. First operation, oh yeah, okay. And then n equals 6, so that should be 4, 2, 0, 4, 2, 0, 1s. And then, so you need to make the rightmost one, and then you can make the middle one 0, and then you can make the rightmost, no, you make the leftmost one into a 0 in the second operation, and then you'd make the rightmost into 1 with the first operation, second operation, first operation. Okay, so it should be 4 operations. This is 2, do 1, 2, 1. Second operation, first operation, first operation. Okay. Okay. So what's the pattern? What's the pattern? So this was ideal. So you need to, in order for the leftmost bit to be changed, which is kind of the first priority, you need to make the second to leftmost bit into 1, and then all the ones to the right of that 0. And the main number of operations. There should be a formula for this. Okay, I don't think you need to actually do the. I don't think you actually need to do the bit operations on it in order to calculate this. There's, yeah, there's. You shouldn't need to do that. So it's hard. I think my guess is it's hard only in the sense that you need to find that formula. Otherwise, it shouldn't be hard, unless you're actually modeling the bit. Unless you're actually modeling the bit operations, or not modeling it, but actually simulating it, performing it. This is not really a simulation if you actually do it. One. So you need to get the first 2 to become 1s, the leftmost to become 1s followed by 0s. So this is kind of ideal case. Like the next kind of idealish case would be like 1, 1, 0, 0. Because then it immediately becomes 0, 1, 0, 0. So I guess a question might be, how hard is it to make it to become 1, 1, 0, 0 or 1, 1 followed by a bunch of zeros? How many steps? Steps in operations to get 1, 1 and then zeros, or 1, 1 plus a bunch of zeros. And then in general, how many steps from 1, 1 plus a bunch of zeros for n-sized number, or n bit number to become 0? Because there should be a generalization of that. Okay, let's go ahead and solve the second part. And I'll solve it by just considering finding the pattern maybe. So 1, 1, that was the initial example, and that gave me 2 operations, 2 steps. 1, 1, 0, that was example 2, and that gave 4 steps. So the next one might be 8 steps or 6 steps would be the pattern. Probably 8 steps, I guess. So if it's 1, 1, 1, 0, 0, 1, 1, 0, 0, it becomes 0, 1, 0, 0. And now you're trying to get the second rightmost bit to become 1. So it's like 1, 1, 0, 1. It's like the 5 rings, 5, 7 rings. What was it called? Chinese 7-ring puzzle? Something like that. 9-ring puzzle. Yeah, it's very much like that one. 1, 0, 1, 0, 1, and then yeah, and then you can make 0, 1, 1, 1, and then it becomes 0, 1, 1, 0. And then it becomes 0, 0, 1, 0, 0, 0, 1, 1, 0, 0, 1, 0, 0, 0. 8 steps. 1, 2, 4, 5, 6, 7, 8. Okay. 1, 2, 3, 4, 5, 6, 7, 8. I guess probably 4 steps to make it actually become 1, 1, 0. Right, 1, 2, 3, 4. This is the first step, second step, third step, fourth step, yeah. And that's this same deal. So this is 4 steps, or 8 steps. Okay. And that binary number is 3, 6, and 3, 6, 12, something like that. Doubling each time, really. Okay. So this is 2 to the power of, so if it's n bits, then it's 2 to the power n minus 1. Steps. Okay. So now it's just a question of how to go from an arbitrary input to 1, 1, 0s or 3 times 2 to some power. All right, let's give an arbitrary example here. Let's say it's 1, something like that. How would I go from this thing to 1, 1, 0, 0, 0? How many steps? Ah. Must be the reverse. So the reverse. So I need to get this. So really it's like getting from 1, 1 to... So I can ignore the starting bit, really. So if ignoring starting bit, and what I'm really considering is like getting that, getting from there to there. One one. It's just going backwards, right? Going backwards. Is that right? Going backwards. So if I want to get this thing, then what was the step before this? Probably the step before this was like 1 0 0 0 0 1, which made it become 1 all zeros. How to grow backwards. How many steps get from 11 and zeros? So it takes 2 steps to make this become 0. So from 0 0 0 1 1 1. It's not quite binary counting, but it's oh so similar. 1. So similar. Normally it's like 0 1, then 1 0, then 1 1, rather than the ordering of 1 1, then 1 0. But the count of it is the same, really. There's 2 things that have 2 bits. And then there's 4 things that have 3 bits. So I could probably... La 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 la. One, 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 one. I feel like I'm pretty close somehow. Just need to be better at recognizing this pattern. I mean, it takes me... Maybe I need a formula for how long it is from 1 0 to get to 0. From any one bit followed by a bunch of zeros to get to 0. That looks to be n to the power 2 to the power of n minus 1 or something like that. 2 to the power of n minus 2 to the power of n minus 1. 2 to the power of n and then subtract 1. Because 1, 0 seems to be the first thing that you would encounter at at the highest, at the binary number that uses those number bits. So if this is using 1, 2, 1, 2, how many bits is this? Using 6 bits. Using 6 bits. So that means it should be 31 steps to make this 0. Can I do the difference maybe? How far away from 0 each number is? How far away from 0 each number is? Maybe. I wonder if I just need to start counting this weird arithmetic. 1, 1, 0, 0, 0, 0. So that becomes 0, 1, 0, 0, 0, 0. Goal here is to get to 1, 1, 0, 0, 0, 0. So I think you just have to go like 1, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 0, 1, 0. It's here. It's 1, 0, 0, 0. That point can go to the next level. So 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 0. I think you would make the second a 0. 1, 0, 1, 0, 1. I think you can make the last one 1. And then I think you want to make this, no, 0, 1, 0. Whoever made this program or this problem likely dealt with the 9-ring puzzle, or maybe modeled it off it, really. I think I lost my train of thought though. Did I do this correctly? Change the last, change the second. Yeah, okay. Yeah, 1, 1, 0, 0, 1. This is very much the 9-ring puzzle. No, it's 1-1. I think this is where you can change that. Wall 1, I think. You need to make this into a 0. No, I'm going backwards. Do. That's correct. 42, line 42 to line 74, so it's 32 steps. 32 steps. Did I skip it? Yeah, I went from 4 to 6. Yeah, so 8, 16, 32 steps. What is the pattern? It's not quite counting binary. Pretty darn close though. Now it looks like just a bunch of zeros and ones, like the fucking Matrix. Which just makes my eyes unfocus. So close, so close, so close. So if I pick an arbitrary value in this whole sequence, how would I break down what is being done here? Yeah, it is getting to 1 1 0 0 1 1 followed by a bunch of zeros. I know how to count from there. So counting upwards, counting from zeros upwards. How do I know how far it is from 0 to an arbitrary thing here? Is that what I'm looking for? Kind of. So if I can count from 0 to an arbitrary thing, and that, and 0 to 1 1, followed bunch of zeros, then I should be able to take the difference. So something like this. So 1 0 1 1 1 0 1 0 1. So this would need to get to this 1 1 0 0 0. So I'm really counting how to get from 0, all zeros, to, no, not really, right? No. That's just the fucking answer at that point. It's going from here to here. From here, say, from there to there. So I know how many steps it takes from here to get to 0. So if I ignore the starting 0, 1, because that's just constant, right? If I ignore the starting 0, 1, can I reduce the problem to something that is easier in some ways? Do 0, 1, 0, 1 to become 1000. 0, 1, 0, 1. Because the first two digits were always going to be the same. Is that correct? Thanks. 0, 1, 0, 1. 0, 1, 0, 0. 1, 1, 0, 0. I mean, yeah, the first two digits were always going to be the same. Otherwise, I mean, or the first digit would always be the same. Otherwise, I'd be dealing with a different problem. Like, it has to be, I'm aiming for something that starts with a 1, second bit's a 1, followed by a bunch of zeros. So the only thing that only places where it should be differing, only places where I'm even possibly considering it to be different would be after the starting 1 bit. So after starting 1 bit, I mean, it could be that, yeah. So it does narrow it down. The starting 1 bit is always going to be starting 1. After the starting 1 bit. So after the starting 1 bit, I want the next one to be a 1 and then a bunch of zeros. The next one to be a 1 followed by a bunch of zeros. So if the next one is currently a 0, then if the next one's currently a 0, then in theory I'm trying to make that into 1. In order to make that into 1, I need to do what? Oh gosh. Okay, if it's a 1 followed by zeros, it's a power of 2 less than 1. So if it's a 1 followed by zeros, then this is immediately coming That's what I'm aiming for. What am I doing? What am I doing? So 0, 1. 1,000. No, should not be calling it 1,000. Wonder if I can just spot the pattern if I just consider these as some version of the translation to binary, from binary to decimal. Okay, I guess it's worth a shot. So this is 1, 4, 1, 2, 4, 4, 5, 7, 6, 2, 3, 1, 4, 5, 7, 6, 2, 3. Yeah, I have suspicion this is just bad process of thought. 1, 2, 4, 8, 16, 32, so 48, 30, 16. 1, 2, 4, 8, 16, 17, 19, 18, 18 plus 4, 22, 23. Oh gosh. Wonder if I can. Yeah. Okay, there's a bunch of 0 1s in front of this. 23 down 2, 21 down 1, 20 up 8. I'm gonna say 28, 29, 31, 30, up 4, 34, 35, down 2, 32, this is 16, wait, oh shucks, there's a 0, 1 here, isn't there? Am I not counting the 1, 0? 16, 17. No, I am counting it. Then am I just off? 16, 17, 20, 1, 21. Oh, what am I doing wrong here? 8, 16 plus 8 plus 4. 16 plus 8 is 24, plus 4 is 28. Yeah. Yeah, I'm doing something. 31, 30. This should be going downwards, isn't it? 30 minus 4 is 26. Wow. 27, 25, 24, 16 plus 8, and then just now 8, 9, 11, 10, 14, 15, 13, 13 minus 1 is 12, 12 minus 8 is 4, 5, 5 plus 2 is 7, I already did this, right? 4, 5, 4, 5, 7, 6, 2, 3, 1. Hmm. 21, 20. I don't know. Do 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 do. So this is 16, right? 16 to 31. And then there's 8 here, 8 to 15. And then there's 4, from 4 to 1. Wait, what happened here? 4 to, from 7 to 7 to 4. Is that right? What's going on here? Yeah, 4 to 7, and then 2 to 3, and then 1. Or 7 to 4, 3 to 2. Dooby dooby doo. 1, 1, 0. So arbitrary number. I guess what was my arbitrary number? It was like 0, 1, 0, 1, 0, or 0, 1, 0, 1, 0, 1. So that arbitrary number, how many steps it takes to get to the boundary. The boundary being either the one above it or the one below it. Like 1, 1, 1. If I look at the rightmost bits here, 1, 1, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, or 0, 1, 1, 1, 1, 0, 1, 1, 0, 1, 1, 1. That's the same as it counting back upwards. 1, 1, 1, 1, 0, 1, 1, 0. So it tries to zero out so I'm zeroing out each thing individually, maybe? Is that what I'm doing? Not quite. So I have this thing 0, 1, 0, 1, 0, 1. So I can try to find how long it takes to get 1, 0, 1 to become 0. Yeah. Never did I consider having to actually compute the formula for the 9 rings problem. So I know from 1 and a bunch of zeros how many steps it takes to make it 0. And I know so the question then becomes, if there's 1 followed by some bunches of non-zeros, like 1 followed by 0, 1, 0, 1, how many steps it went from going from all zeros to that amount, and that will be the reduction of how many steps it goes from 1 all zeros down to 0. So this thing here is going backwards. However long it takes this thing to get to 0 is how much I subtract from the overall steps. So then the question is how long it takes to get this to become 0 then. And I know how long it would take to get if it was just 1 followed by zeros. So then I'm looking, okay, I can almost see it. Almost see it. Okay. So let's take an arbitrary one. Let's say it's 1, 0, 0, 1, 0, 1, 0, something like that. So I know that 1 followed by needs 2 to some n power minus 1 steps. I think it's going to be, what was it? So this was 8 steps, and then this is 7 steps. So I think it's this thing plus 1 is the power of 2. The power of 2 is whatever bit index this is, or the number of bits this is. So if it's 1, 0, 0, there's 3 bits there, so it's going to be 2 to the third minus 1. So here it's 4, 8, so it's going to be 2 to the 8th minus 1. So it's going to be 2 to the 8th is 256, I think. Okay. So then the question is how long it takes to get this thing to become 0. And let's call that k, and I would need to subtract that from 255. So I know for 1010 it would eventually need, I know that 1000 needs 2 to the 5th steps minus 1. So that's going to equal 31. And then, so therefore the next question is how long for 101 to become 0? And let's say that equals p. I subtract that from 31. So I know 100 requires 2 to the third minus 1 steps. So that's 7. How long for the 1 to become a 0? That equals, let's say, r. Subtract that from 7. So that is, well, 1 becomes 0 in 1 step. So that makes this 6. 6 subtracted from 31 is 25. 25 subtracted from 255 is 230. What is this number in decimal? $149. Hopefully AI is correct here. To 230. Okay. Okay. I think I got the idea. Yeah, I think I got the idea. Okay. So I need to figure out how long this is in binary. How do I convert? I need to convert it to binary array, I think. I think I just need to look this up. Python convert number to binary array bits. What is the fastest way of doing that? Bin numpy bin. Interesting. Bin string number convert. Bitwise operations. I think it's probably better to, I mean, I wonder if this is faster. Probably should get used to doing this way, maybe. Yeah, binary bits. This is going to be backwards now. You have your bit array for I in range bits minus 1, often for a fixed bit length. Okay, I guess you can make it, yeah, okay, this bit is going left to, it's going right to left, but then they're storing it in, no, they're not really storing it. They're appending the bit to an empty list. This feels like it's backwards. Okay, so let's go for, I guess backwards is fine. I think maybe I'll just use while n is greater than 0. Bits append, actually, bit is going to be n and 1, bitwise and 1. And then, they actually did, and then n shift 1 over to the right with shift, yeah, and then bits append. I guess I could just do bits append n and 1. Okay, I wonder if this is going to be enough information for me to figure out that this is correct or incorrect. Whoops. I think this is backwards. Yeah, 6 is 0, 1, 1. Yeah, this was backwards of my 149 example, but this is fine. This is backwards binary bits. So let's say size is equal to length of bits. I'm going to say answer is initially 0. So it needs to toggle backwards and forwards, I think. Because the way that the calculation works, the first time it calculates, it uses that as a positive value, really. And the next calculation, it's going to subtract. And the next calculation is going to add, because it's subtracting from this. Kind of, yeah, alternates how it alternates subtracting and adding in net, because this thing is subtracted from this thing, which is subtracted from this thing, so it basically adds this thing. Okay. So I think I need maybe an add toggle. And the initial add toggle is true. So I guess I want to just go through the indices, where the indices represent also the length of the number of bits there. So for index and range, size -1, -1, -1. So decrementing it. Answer should increase. So if it's adding, then answer, it's not, probably an easier way. I guess I need to skip over the zeros. First off, if bits at this index equals 0, continue. And then add toggle. I think I can do something like maybe add toggle should just be +1 or -1. Answer equals add toggle times 2 to the power of index -1. Add toggle times equals -1. And I think that's, oh, there should be plus equals. think that might be right. Oh, not even close. Okay. 115, 2. I wonder if I'm off by a factor of 2 or something. 115, where the answer should have been 149. 230. That does seem like it's off by a factor of 2 somehow. Given the fact that it's 115 and 230, and 2 and 4. Where did I go off by a factor of 2 though? Should be 2 to the index minus 1? Minus 1? Or 2 to the index plus 1? Yeah, it might be 2 to the index plus 1 actually. Yeah, I'm pretty sure. Index, it's going to be the size of the thing, and 0 index is 1 size. Yeah. I guess I can possibly just keep it like this, and then just return answer times 2. Shucks. Okay, 333. Huh. How odd that this would be where it fails. 333. Okay. So what is it doing? It's doing it incorrectly. What would it be doing incorrectly and off by 1? Such a small amount to be off by. Do. 10, 100, 1101, 10, 1110. What? Oh, I'm reading backwards. 10, 100, 11101. Okay. Somehow it's not toggling correctly. Okay, let's go ahead and just dive deeper here. Let's go ahead and do this. Actually, I think I want to know the answer as it currently stands. Okay. What? 196? Oh, fuck. Okay, I think I do need to just modify this to be correct all the time so I can parse what's going on. Okay. Wait, what? Oh, I'm a dum-dum. Okay. Yeah, definitely that little... That was just all stupid. Alright, cool beans. Okay. I don't need this. And answer plus equals that. Add toggle. Guess maybe I could just make it bits initially have 0, kind of a dummy. So then the index is always correct. So then I don't need to worry about index plus 1. I just use index. That's fine, that's fine. Don't need parentheses. Add toggles. Guess I can just say bits append and bitwise and with 1. And shifts. Oh, mother. Did I not do this correctly? Where did I screw up here? 0. Was it the fact that I added the dummy 0? Shouldn't have been, I don't think. Was it changing it from bit equals n mod n and bitwise 1? That shouldn't have been wrong either. What's going on? It's all wrong. All very wrong. Guessing it's the dummy part. Can't imagine it being wrong from the changing the bit variable. It was the bit variable? Why would that be wrong? What's going on? What did I change here that made it so wrong? Answer plus equals value, where value is... Oh, fuck. I forgot. I removed the toggle. No wonder I had the parentheses. Can't. I don't even know what I was thinking. Okay. Yeah. This definitely should be able to do this syntax. Should definitely be able to use a dummy. So I should be able to get rid of the +1 here. kind of scary. Okay. And I'm guessing it's going to be the same speed. Wow, that was a lot of stuff. Okay. Alright, I think I'm going to leave it like that. So summary here is basically a binary type math problem. Very, very similar to the Chinese nine ring puzzle. And just a kind of computational form of it. For any given state, where the state is the binary number, it takes some number of steps or operations or moves in the puzzle to get to the 0 state, which is like 0. Leverage that in the calculation. So with the understanding that a state of 1 followed by a bunch of zeros, or basically i.e. a power of 2, requires 2 to the x minus 1 moves to minus 1 steps to get to 0, where x is the number of bits in that state. Can do subtraction, can do alternation of subtraction of inner bits for the overall calculation. So just look at the example here. So if you have a binary number, you're trying to get basically, you already know what 1 followed by a bunch of zeros is. So in order for you to go from 1 followed by a bunch of things that aren't zeros, then you need to find the number of steps that it would take to change those things to become zeros. Let's say that's going to be k, and you subtract k from 255 because 255 is how much it takes to get this power of 2 to become 0. And then that becomes kind of a subproblem. You can do this. You can also do this recursively, I think. But how many steps to get from here to become 0? Well, that's 2 to the power of 5 because 5 is the number of bits there minus 1. So that's 31 steps overall for that. Then you want to get the 1, 0, 1 to become 0. So let's say that's p. You need to subtract 31 by p, so on and so forth. So this last thing was like subtracting 1. 1 subtracted from 7 is 6. 6 subtracted from 31 is 25. 25 subtracted from 255 is 230. So it takes 230 steps here. And the alternation and subtraction of the inner stuff is going to lead to an alternation of signs for the number of steps for each bit. Time complexity is going to be O of B, where B is the number of bits in the binary number. So very fast, as it's a very finite number of bits. You can almost consider this constant speed. which is why it's 0 milliseconds. So base complexity of this would be to convert number to binary array bits for computational work.